Remember the formula for the thrust of a rocket? The up force. Do you remember? No? Oh my goodness. It was
Time speed. That's the time thing we do. Speed.
Speed of what?
The gas.
Yep. Multiplied by?
Weight of it.
Ooh, close. The mass of it. Yeah. Yeah. Okay. Right. So let's continue with that one, okay? I did an example very quickly for it, but just as a warm-up, let me do another quick example. Where were we? No, was it that? This was it here. Yeah. So, for example, let's say we have our rocket and we have our gas coming out. So let's say, yeah, I'm just doing another example as a reminder. So we'll say that the gas comes out at, let's say, I don't know, 1,000 kilograms per second. That's how much gas comes out per second. And let's say the speed of the gas when it comes out per second, I don't know, let's say it's 2,000. Oh no, that's too fast. 200 meters per second. So the formula for the force of a rocket is delta M, delta V or U or whatever. How much gas per second multiplied by the speed of the gas. So in this case it'd be 200,000, what's that, 200,000 newtons? Yeah, so 200 kilonewtons as an example. Okay. So do you remember this?
Yeah.
From yesterday? Yeah, okay. I don't think there's anything else to say about that. I know I did it very quickly yesterday, but is it okay? Yeah, it's okay? Alright. So, there's another example now. By the way, I should say that both these examples I'm doing, I've seen them in past exams. The rocket example, and also this wind example. And then I think what we'll do after I do this example, oh wait, we have these to do. I asked you to do 1 and 2. Did you do those?
I did number 2, but I didn't do number 1.
But number 1 was easier. Okay, but you did number 2.
Yeah, but maybe number 2 is wrong.
Yeah, I did them.
Okay, alright. Well look, what we'll do is I'll do this example and then we'll have a tutorial on this. You were supposed to do 1 and 2, is what I said on Wednesday. But anyways, let's have a look at the question here. So, I think it is good if you can write this down. Because it is a bit difficult.
You should write the data.
Well, if you're confident with your English, that's okay, but I really would prefer you to write it all down because it's quite complicated.
Physics student was okay.
Yeah, I have to make it a physics student.
A favor for physics student.
I have to make it. Okay, did you write this down?
I'm writing.
Yes. Okay, did you write this down?
Yes.
Yeah, okay, so let's have a look at this then. So we have, it was a windy day and a physics student was walking home. The student stops for a moment to calculate the force he is feeling from the wind. The wind was blowing at a speed of 12 meters per second into the student, and the student is 1.6 tall and 40 centimeters wide. So let's draw what's happening here. Okay, I'll try and make this 3 dimensions for you. Right, this here is the physics student. It's a rectangle. How tall is the physics student? 1.6. And how wide is our ugly student? 40 centimeters, is it? Like this? Yeah. Okay, so think about what's happening here, alright? There's wind blowing in, hitting the student, and how fast is this wind blowing at? 12 meters per second. So you know from experience, when you're walking in the wind, you can feel a force pushing you, and you must push back to cancel this force. So the force that the student feels is the same force they must push back to cancel it here. So the question is, how can we calculate how big that force is if all we know is the speed of the wind? Because you know that if the wind's blowing faster, then, you know, that's more force.
The density of air is 1 kg.
And we'll deal with that in a moment as well, yeah. Yeah. So if you really think about this hard, you realise that this is the same as the rocket example. Because what happens here is a gas, air, is pushing something. So in the rocket, the gas is pushing the rocket up. In this case, the wind, the air is the gas. So what you need to imagine in your mind is a big rectangle in front of the student. And this rectangle is 12 meters long. Now why do you think I'm saying it's 12 meters long? Where do you think I might be going with this? Yeah, but why would I say distance is 12?
Because 1 second.
That's it. In 1 second, if the wind is blowing 12 meters per second, it means in 1 second the wind has travelled 12 meters. So in other words, what I'm saying is all the wind in this rectangle in 1 second gets pushed to the student. So this is just like with the rocket where all the gas gets pushed out in 1 second. So in 1 second, all this gets pushed into the student. And this is what creates the force. Now, if we think about it as a rocket, what's the formula? The mass per second and its velocity. Now, we don't know the mass just yet, but we definitely know the velocity. What is it? 12 meters per second. Now we have the job of working out the mass of all this air that gets pushed into them in 1 second. Okay. Using the density formula. What's the formula for density? Mass over volume. Yeah. So then mass equals density times volume. So then this formula now becomes density volume times 12. Now I told you what the density of the air is in the question. What is it? It's just 1 kilogram. It's quite light. So it's just 12V. Now, can I calculate the volume? Yeah, it's this, multiply this, multiply this, multiply 12. So let's see what we get. 12 times 12 times 0.4 times 1.6. And the answer is 92.2 newtons. So that is the force the student feels from the wind. Continuously. But we look at it as a 1 second period for the calculation. But as long as they're standing there and the wind's blowing, it'll be a constant 92 newtons of force. So if I just kind of draw what's happening, here is our student. How much force is blowing him backwards? 92.2 newtons. If he doesn't fall down, it's because he is pushing forward with how much force? 92.2 newtons at a constant speed or at rest. Yeah. So you've worked out how much force the student is exerting to prevent the wind from blowing him down. Okay, so if you can, here, so you can write this one down. Yeah.
But when the wind is pushing the student, it's 92.2.
Yeah.
And how, when he pushed the force, how it's 92.2.
It must be equal to cancel, to balance. You know what I mean by balance? If the student's not moving, if the student is standing still,
Will push him.
if he doesn't push back,
If he doesn't push him.
yeah, he'll fall down.
Yes.
Yes. Okay. This was an exam question. Now,
Okay.
can you understand that the calculation is simple, the idea is difficult?
The 12 meters per second. But the hand is
It's like
not,
it
so-
is.
Okay, so I'm going to give you something advice. My experience of teaching physics is that students do not do as well as they do in the exam because they don't study as much as they should study. And the reason they don't, I really think the reason students don't study physics as much as they should is because when they look at this in class, they think this is easy. This is so easy. Piece of cake. I don't need to study this. I need to study chemistry. I don't need to study this. And then when you sit down in the exam and you get a question like this, you haven't any idea what to do. Yeah. So please do not be tricked into thinking, oh well, just because I saw it done and Stephen made it look easy, it's easy. Okay? It's not. This was difficult because you had to completely understand what was happening completely. Okay? And the only way you can get good at these is by practicing them. So what we'll do now is we'll have to do tutorial, but I think because we didn't do all the questions and people didn't do all the questions, what we'll do is we'll alternate between you and I doing the questions. So what will happen is we have 4 questions. I'll give you a few minutes to do the first question, then I'll do it. Second one, then I'll do it. The third one, then I'll do it. Okay? And then let's see, what have we got to do after this? Yeah, the next lesson is very easy. I think 3. How many weeks until the midterm? Is it 3 weeks?
Midterm is before the holidays or after the holidays?
Yeah, in other words, how many classes until the holidays? How many? How many weeks? 3 weeks, is it? It's 3 weeks, I think. Yeah, it is 3.
The 3 weeks holiday.
When are the midterm exams?
Okay.
Are they before the winter break?
I think that after, when you come back from the 1 week break,
And when
Oh, so-
semester 2, semester 1 again?
I'm not thinking that far ahead.
It's after the holidays.
Okay, I'm going to close this.